In this problem, we're asked to consider a gas pressure measuring device called a manometer. And in particular, this one is open to the atmosphere. So they say it's an open-ended manometer. That relies on atmospheric pressure to push on one side of the mercury in a curved tube, and the gas sample that you might be curious about to push on the other side of the mercury in a curved tube. Take a look at the situation on the left here, situation A. The atmospheric pressure is standard 760 torr. It's pushing down on the mercury with that much pressure. Where the flask is connected, it's pushing down on the mercury on the other side. But in that battle of pushing on mercury, the atmosphere is winning. That is, the mercury is sloshing over to the side of the manometer where the flask that contains the gas sample is. For us, that means that the gas sample has a pressure lower than atmospheric pressure. And to calculate the exact pressure difference, we need to know the difference in height from one side of the mercury in the tube to the other. They give us that height in the problem. HA, or the height in situation A, is 138 millimeters. And if they told us earlier that the pressure of the atmosphere is 760, to calculate the pressure in situation A, we would take 760 minus 138, because remember the gas in the sample is lower than atmospheric pressure, and that works out to be 622 torr. They also, just to get you familiar with answering pressure in different units, ask you for that same pressure in both atmospheres and pascals. Well, to do those conversions, it's helpful to remember that 1 atmosphere is equivalent to 760 torr, which, by the way, is the same as millimeters of mercury. So mmHg is another unit exactly the same. And all of those are equivalent to 101.3 kilopascals of kPa. So to make the conversion from torrs to atmospheres, we'll just set up a simple conversion factor, making sure that our units cross out. 622 torr. And first they want us to get to atmospheres. Well, I know that 760 torr are equivalent to 1 atmosphere. The unit's torr crosses out, atmospheres is left over. And we get, in this case, 0.818 atmospheres. For the unit in pascals, well, we can carry that a little bit further in our calculation. If we know that 0.818 atmospheres is the pressure, and we know from our equivalent statement above that 101.3 kilopascals is equal to 1 atmosphere. And if we know our metric prefixes, we can just say that a kilopascal then would be, oops, hold on one second. .818 atmospheres, and we want to make sure that atmospheres is on the bottom of that conversion factor so that atmospheres crosses out. And if we know our metric prefixes, a kilo of anything is 1,000 of that base unit. In this case, it's a pressure unit, pascals, and a kilopascal would be 1,000 of those. So if you follow how the units work, atmospheres crosses out, and kilopascals crosses out, and pascals is what is left. So on my calculator, I'm typing 0.818 times 101.3 times 1,000, and I come up with 82,900 pascals. Next, in situation B, let's take a look at this one. Here we have the atmosphere pushing down on the mercury in an open-ended manometer, and the pressure of the gas in the flask pushing down on the other side of mercury in an open-ended manometer. But this time, the gas sample is winning in that battle. The pressure of the gas in the sample is greater than atmospheric pressure. So to calculate the pressure of the gas in the sample, we need to know the height difference from one side of the mercury to the other, and they give that to us. The height of the mercury in situation B is 240 millimeters. So to calculate the pressure in torr, we simply take atmospheric pressure plus 240 and arrive at 1,000. Then, just like in part A, they want us to convert that into both atmospheres and pascals. So that's just some unit conversions. And so long as we remember that 1 atmosphere equals 760 torr, which is 760 millimeters of mercury, and that all is equal to 101.3 kilopascals, then we can make any conversion happen. So let's start with torr to atmosphere. We'll write a conversion factor with torr in the denominator and atmospheres in the numerator, so that torr crosses out and atmospheres is what we're left with, and we arrive at 1.32. To answer the number of pascals, we can keep working with those different units. Let's start with what we had worked out earlier, the pressure in atmospheres. For every 1 atmosphere, there are 101.3 kilopascals of pressure. And for every single kilopascal, there are 1,000 pascals based on our metric prefixes. So on my calculator, I'm typing 1.32 times 101.3 times 1,000, and I arrive at, if we convert this into scientific notation, 1.33 times 10 to the 5th pascals. And with WebAssign, you can use the E notation, so 1.33 E positive 5 would be an acceptable way to write that. In part C, they're asking about pressures in torr for both situation A and situation B, but this time they say that atmospheric pressure, instead of being 760, is now 695. So if you remember situation A, atmospheric pressure was greater than the gas sample pressure, and so we had arrived at the gas sample pressure by subtracting the difference in height from the atmospheric pressure. Well, we're going to do the same thing, except this time the atmospheric pressure is different. So case A, 695 torr minus what they had given as the height difference between the two sides of the mercury, 138. And we arrive at 557 torr. In case B, this time we add the height difference to the atmospheric pressure. The atmospheric pressure is 695, and in situation B, our height difference was 240 millimeters. So 695 plus 240 gives us 935.